Welcome to the wasmCloud Machine Learning Weekly Biweekly Call. This is April the 14th, 2022. Christoph, Andrew, Steve, I guess we should probably start with the state of the demo. Christoph, you've been making a ton of progress, and we've got now pre-processing and post-processing, as well as the sort of core work here working, and it's working with a bunch of different models. Steve, you did a demo on the wasmCloud call on Wednesday, just yesterday. Is there anything else that we should review as far as what the state of the demo is now and where things are?
One of there's some minor tweaks, but I think those are probably lower priority than moving ahead with the next features for the demo. I think so. Tweaks, we can clean up the output. Another tweak is doing performance benchmarks and figuring out places to optimize. But I think it's a little too early to try to pay a lot of effort into optimization. We could do a web-based demo, but that sort of goes in line with features of the demo. So I think it's pretty good as is, and until we decide on the next steps forward. We'd love to hear what other people think.
Christoph, what do you think?
Yeah,
You've started to socialize this bit with some broader communities. What was their response, or where, or what was your perspective on that?
I would totally agree with Steve. So we've got a super base. Let's agree how we can make that even larger, better, prepare for the future. But we're good to go.
That's great. Andrew, I think you kind of asked an interesting question around like what does this demo mean for us in its current state? And so I think what we have now is we have TensorFlow with a couple of the standard image detection models configured, which is a demo that you can do anywhere. But I think what is powerful is that we know that in order to use these models that there is both pre and post processing. So I think one of the things that this demo means that we can materially think about demonstrating through some performance benchmarks or something is the ability for pre and post processing to seamlessly move in a standard way, right? So now when we think about what it means to have the sort of portability that wasmCloud brings, it means that we could be conducting either of those things either locally, remotely, or varying combinations thereof for testing or for other things. The second thing I think that distinguishes this demo, Andrew, is that the ability to mount the capability providers, whether they're local or remote. So you could acquire an image from a local device, but mount a capability provider that's remotely. And in another way, how you would do this is, you would create some client server structure, just submit it via a REST call or something like that. But I think this way is incredibly simple because the developers don't need to change any of their code in order to execute, design a process for consuming machine learning, and then implement it. Deployment topology becomes a detail. Becomes a deployment detail. It doesn't become an architectural criteria that I have to bring into my code. So that's the second thing that I think that it means. And then I think there's a broader third thing here around the connectivity of this in like this is now so easy to take a set of code, and because it's already tied into all of the other ones, I think that this really opens up, an architecture that's very popular. You think like Nest type architecture where you've got a lot of edges and endpoints. This just makes building those things very easy. So I think the combination of distributed with wasmCloud plus machine learning does unlock a few powerful demos. Are there other things that this demo means today that that I didn't accurately account for? And my list was pre and post processing. All this stuff around the machine learning has portability, the ability to locally or remotely mount capability providers, and the sort of architectural collaboration this unlocks. Is there anything else that you guys would highlight?
Sounds about right to me. Can I rewind to ask a couple questions about the original? Yeah. Not to derail too much here, but with the pre-processing that you guys have built so far, are you happy with the results that you're getting back from the models? In other words, is the classification working correctly? Or are things getting garbled during the pre-processing step?
Now that, yeah, Steve.
Oh, go ahead, Christoph.
My answer is not very, very good, but I wanted to say, yeah, looks more or less right. But if you look after the content, I didn't try to prove it or didn't do benchmarks or content-wise test. Hope that is fine. Yeah.
But at least in just the smoke test that you ran, it looked like it was classifying the image correctly. Yeah. Okay. Cool. Okay. And then
yeah, I've tried with about 15 different varied images from the web, JPEG and PNG, and it's looked fine, great on all of them. So I would add a caveat to Liam's Liam's statement about where we are in terms of architecture. I think this architecture is still in the prototype stage, and even the block diagram that I showed in the community call yesterday, I think that could change once we get further along and into a demo that's more realistic and more full featured or plugged into a real world application. I don't think we would want to declare that we've decided on the right architecture entirely and people should just go and run with this now. I think it needs some more proving out in real world, and that's partly related to performance issues. I know there's some things that Kevin and I have been talking about response time that will probably rear their head when the models get a little more complicated and the response time increases. So there's a few subtle variations. I think we're going in the right direction. I don't think we've made any I'm not aware of any completely wrong turns, but we might make a 30% course correction in the architecture once we get more experience with it.
Okay, so let me play that back to make sure that I understood it, Steve. Your suggestion is that we take what works now and we try to load larger models into it, maybe try to run things through it at a higher rate, and we look at where things are maybe aren't meeting our expectations, so that we can understand if we have to do some architectural changes now before we go too far down one path or another. Did I say that right?
Yeah, so I guess the term architecture is a little ambiguous. So what I was thinking nothing you just said is wrong. What I was thinking about was the topology of, so the way the message passing works now, we send the image to the API actor. The API actor calls the preprocessor, and then the inference engine, and then the post-processor actor. And that's part of something that I think could change. Maybe the message goes in a different direction, or maybe it starts at the preprocessor and then goes to API. So some of those kind of things might change. And those are the kind of things that if we were to tell people 10 developers to go off and build your application with this, the variations in those would cause a lot of duplicate work and maybe some frustration. And so those are things where it's not just that I want to test with bigger models or more complex models, but I also want to test in some real world applications, ideally in more than one domain, so image plus something else. But getting that real world application in there, and all the other things that that's going to require for the flow to work, I think is important before we say that we have confidence that this is the architecture we want to recommend for people to use ML and wasmCloud.
Sounds smart.
Christoph, you got
Yeah,
your...
you open for a feature request. Maybe this is a good time to introduce again what I maybe once called a low latency mechanism. So I dream of something where maybe there's an intermediate actor, something which intermediates between our today's capability provider, which does the inferencing, and a new capability provider, which represents a data source. Like regardless of if it be a camera or something else, you know, the source of some data, and like shuffles that intermediate actor could shuffle data hence and forth, or like pulling images, whatever, stuffing that to that inference provider, and put or send the results somewhere else. And what I remember, Steve, you mentioned once some async actors or so. I would like to try some of these for that mechanism.
Yeah, so that work is in progress. So for the other folks on the call, we still have a default 2-second response time anywhere in the chain for any RPC message, and that includes from the HTTP server to the first API actor, because then all of the other things that happen, the pre-processing, the inference, the post-processing, those all together cumulatively have to complete within 2 seconds before the API actor returns to the HTTP server. And if it takes longer than 2 seconds, it'll get a timeout. You can increase that timeout with a system-wide configuration, but what Kevin and I have talked about, a way to send fire and forget messages from actors, and that'll allow different kinds of topologies, and it'll allow paths that take longer than 2 seconds. So that's in progress. We should see that that change soon, probably within a couple of weeks. But that's separate, and so that might actually influence the topology that we end up recommending. And there's also some other things. I know Andrew had brought up the idea of trying to get zero copy in the tensors. That if, as we dive into that, so I put that under the category of performance optimization. As we get into that, the API will probably change a little bit. So that's another thing that we'd like to get a little more practice with before we tell a bunch of people to go run with it. I'm sorry, I hope I'm not going too much into the weeds on this.
No. So, Christoph, what I hear from Steve is before we go down the zero copy approach, that we should maybe try to, Steve, I don't know if you have a specific proposal here. Like, do you think we should spin up a couple models ourselves and just run them? Like point a camera out my window, run the dog recognition model, and figure out what's the most popular dog walked in a suburb of Washington D.C. What do you suggest? Or we try to find and recruit a couple folks that are building things like Christoph. Maybe you have some concepts that we could lean in and help out to get up and going, to try to generate some data and some experience with this.
So if I answer, there's a lots of potential benchmarks out there. I would just grab some existing stuff. For example, the other week I switched on for the first time that rather new Coral dev board and run the demos which are in that, which are shipped with that board. There are some nice things, and many of them deploy also that mobile net model. So one of these we also have here. We could more or less easily compare the results. Maybe that's a good start.
So you want to use some of the existing benchmarks that are already shipped with the Coral. We set them up in wasmCloud, and we see what the difference is running them through there. What's the test harness that the Coral has? Is it just like some Python scaffolding or anything like that?
Yeah, it's C++, and it has a Python wrapper. But the core is C++. So the core is TensorFlow Lite. That's a C++ library. Which I'm entrained to. I mean, I compiled it on my PC. I would try to integrate it even in our ML inference provider. So one of the goals, don't know how important that is to run that wasmCloud on that Coral dev board and use it the Edge TPU, which is the accelerator of that dev board. So that would be my ultimate demo also for my use cases, which I really target. So for industrial use.
Yeah, that'd be pretty interesting to see. See what that looks like. In terms of your question on the Slack channel, are you envisioning that at the wasmCloud level, users will be able to see the different hardware that's performing the inference, right? Or like, would the fact that the inference is being performed on a TPU be exposed at the wasmCloud level or not?
I didn't understand the question, I think.
It should be transparent, but we could expose it in terms of adding information to the response. If you want to use that information for routing the request, we could also try to come up with something that's somewhat abstract, like maybe a choice of optimize for speed or cost or something like that, and then have some router decide. We try to keep architecture specific stuff out of the messages, but if there's a kind of some goal parameters that might make sense to add to the request, we could figure those out.
I think actually I was leaning the other way towards not exposing that type of information at the wasmCloud level. That, you know, I was just checking to see, and it sounds like what the proposed path would be. Well, the capability provider just runs either on the Coral dev board or on some other machine. wasmCloud really doesn't know the capabilities of that machine, but the capability provider itself does, and it can choose. It can say, oh, I see I have a TPU. I'm going to use the TPU. Oh, I don't have a TPU over here. I'm not going to. I'm going to use the CPU. Right? Is that sort of the model we're looking at here? Yeah.
Yeah, that's correct. So the provider could decide which of the available resources on the current host where it's running it wants to use. In addition, there is some network smarts built into wasmCloud, and so if your edge TPU is closer, like connected to the same NATS leaf node, then all requests will go to that by default. But if the edge TPU is not on the network, but there is something in the cloud, if the same capability provider is running in a cloud server, then it will route to that. So we'll get the kind of failover scenario that you and Minkyu were talking about.
Yeah. Cool. And then potentially in the future, the QoS side of this, where the attributes exposed at the wasmCloud level would be QoS based, not, architecture dependent stuff.
Definitely.
Right. We'd be talking about latency and throughput, not about TPUs and GPUs. Great. Cool.
Okay, so I'm kind of feeling like we have a consensus here on a path forward here for next steps. It sounds like the demo, Christoph, that we're going to do is we're going to maybe focus on the Coral Dev board. Steve, if you don't have one, I can send you one if I didn't already. And we're going to pull some of the sample examples that they have, and we're going to try to configure the same examples in wasmCloud locally, and we're going to just compare them side by side and use that as a baseline for how we think we're doing. And then we'll use the results from that in order to understand what we think the next direction is for the demo. Christoph, I guess you didn't hear that. You may have stepped away for just a minute. I had said it sounded like we have some consensus that we're going to try to recreate or clone some of the default Coral dev board examples using the TPU. We're going to configure them in wasmCloud and just run them side by side and see just what the initial pass at the differences between the two. And then we'll use the output of that to understand where we need to pursue and where we invest our efforts from the demonstration perspective. Does that feel right?
Yeah, that's a very good idea. I'm very curious, not only to run models on the Edge DPU, but also on these ARM cores, because I read that the inference engine we use, that track, that shall be optimized for ARM cores, because that guys who wrote it, they had ARM in mind. So I'm really, you can on the dev board also run the inference on the CPU, right? So I'm really interested to compare.
All right, Steve, Andrew, are we all in agreement here on what our next steps are?
It's okay with me. What do you think, Andrew?
Yeah, it's sounds like a good plan. I don't have too much skin in the game right now, so I will cheerlead at the moment, but
Well, Andrew,
sounds good.
I think we're heading towards this. Is sort of gives us the kind of like test for your use case, which is
Yeah.
making decisions based on some of that, right? And
Yep.
us
Yep.
rerouting as needed. Do you feel this is a prereq that this will get us one step closer to the demo that you want to see done with this?
Yeah, I think so. Because that's a couple weeks ago or a month ago, I don't know, I was talking about we need the data, right? We need to understand what is the performance at the edge and what is the performance in the cloud. And as you guys are running these experiments, if there's a way to capture that in a wasmCloud accessible way, then that can inform the QoS attributes that we were talking about earlier.
I like what we're thinking about here, like the QoS of ML, like yeah, there's something there, like the
It's
routing.
hazy. It's hazy still, but it's if you know how many, if you knew your throughput or your latency down at the edge, then you can start making decisions based on that.
You can start to decide, is it worth it to process this locally or pre-process it versus offloading it. Yeah, or at least what the trade-off is. If I'm offloading, I'm going to get 1 frame per second, but I'm going to get this level of introspection. If it's local, I'm going to get 30 frames per second. But it's only going to be really lightweight. Maybe I want to strategically. Maybe it could be adapting that rate to do the lightweight model and the heavyweight model. There's a lot of different areas we could go in with this.
Yeah, the self-adaptive thing, that'd be extra credit right there.
Adaptive ML would be super extra credit, right? Because then we would get to call it AML and we'd have a conflict with anti-money laundering, right? On the abbreviation, which is just always a win in tech when you can just muddle the communication even more. All right, I love this. This is great. Okay, so do we need to talk about who's gonna be Steve and Christoph? The two of you seem to be doing a great job managing the work now between the two of you. Do we need to talk about any of that, or do you guys want to align on anything, or do you guys just gonna hand wave and just continue to make magic happen? Sort of like when the fairy godmother comes down and just waves her wand and the pumpkins get up and dance. That's what I feel like happens here. You guys it's amazing.
Yeah, bibbidi bobbidi boo.
Bippity boppity boo indeed, Steve.
Yeah, Christoph and I can follow up on Slack to fine tune.
Right. Yeah, I think so.
All right, well, bippity boppity boo. I guess that is the end of this week's call. I'm going to go ahead and stop recording. We can hang out. Have a great week.